Es un honor para mí poder presentar e introducir al doctor David Malkin, Product Management Director en Cogent Labs, nuestro Keynote Speaker convidado desde Tokio. David Malkin completó su doctorado en informática en el University College of London, que se centró en sistemas inteligentes y técnicas de optimización inspiradas en la biología. Después de sus estudios, David trabajó en la industria financiera en Londres, utilizando el aprendizaje automático para desarrollar algoritmos comerciales de alta frecuencia. Previendo el enorme impacto que tendría el aprendizaje automático en la industria, David estableció una empresa de consultoría de inteligencia artificial en Londres para ayudar a las empresas a utilizar el aprendizaje profundo y otras técnicas de aprendizaje automático. David se unió a Cogent Labs, una empresa de inteligencia artificial en Tokio, a inicios de 2015, donde ahora trabaja en el desarrollo de productos. Let's switch to English. David will present us Building Deep Learning Powered Products, a Technology and Business Perspective. So, please, David, the floor is yours.
Good to be here, so thank you. So just to give you a quick overview, so today, a little bit, I'll talk about the product that we've built in the company in Tokyo, not because of the product, but it's interesting to kind of see some of the real world things that we've done and then connecting them with sort of the reality or the theory, sort of the logic of how to build an AI or a deep learning business. And then I'm going to talk a little bit about some of the challenges and some of the solutions we had of moving into actual production, like real world systems with real customers and some of the real challenges around that. And then a little bit, at the end, we'll talk about AI or deep learning for B2B in the B2B context. And then a little bit about B2B in Japan, just to give people an idea of maybe some of the differences between Europe and here, and maybe some of the opportunities. So as I was introduced already, I started my journey in UCL, and this was about 20 years ago. And when I studied AI, actually out of 20 people on my course, about 11 quit because they didn't think that AI really had a future, and everybody went to do telecommunications. So it's kind of interesting that sometimes a technology that is not actually that popular becomes sort of very transformative. So that was a sort of a good choice. Basically after that, I moved to the city of London. And what was interesting here is that you could see, sort of this is, maybe about 10 years ago, you could see that machine learning was really starting to make an impact into some of this kind of high frequency trading and the trading algorithms. And you could see that machine learning was really starting to move away from just sort of academic into a real business application. And while it wasn't deep learning really at the time, you could just see that machine learning in itself was really starting to be used in the algorithms. And after that, basically about 7 years ago, I joined a startup in Japan. And this was the office. It was basically 4 of us. It looks like a cafe. It was a working space. And this just hit during the boom when the AI funding really started to come in, and there was a really big wave, and a lot of money was coming into the area. So we raised a Series A fund for about $14 million, I think, for a Series A, which is very, very unusual actually. So we moved into a new office. Things really quickly started to move ahead. So we generally would hire internationally, sort of the engineers, deep learning technicians, engineers, scientists, whereas it was Japanese staff to do sales and marketing and everything else. And that just continued. So now we're basically about 80 people. We've moved into a new office. We've got hundreds of clients, some of the top banks in Japan, the Japanese government, etc. So there was this real big move in Japan, at least, and I think globally, for applying deep learning technology to solve some of these sort of real world problems. So what we focused on is basically trying to understand documents, both handwritten and printed documents. We created a product called SmartRead. And the notion here is very simple. Instead of typing in the information from a document, how could we get that information automatically into a database? So the problem sounds very simple and straightforward. As we started building this, we realized that actually, the challenges around such a simple thing are actually immense. And so I'm going to share some of these things that we've learned along the way. Just as a bit of information, like it may, if this is data from Japan, is that the amount of data entry still here is absolutely humongous. And so purely from a business perspective, while people think that Japan is very advanced, it's actually very advanced in terms of manufacturing. And so when you look at the Japanese economy, the productivity increases have gone up every year for people in the manufacturing sector. So, you know, you're thinking cars, you're thinking electronics, heavy machinery. The Japanese factories are extremely efficient in this kind of thing. Very inefficient in terms of the service industry. So for example, banking, insurance, it really is at a very different level. And so there is this very big opportunity of addressing the sort of B2B service industry improvements and the use of AI in Japan. So customer support, data entry kind of work. It's a really, really big opportunity. Still the third largest economy in the world. So there's a very big, interesting business opportunity there. So I'll give you just one example of one of our customers, very south of Japan, all the way down. And I flew down, it's in a city called Kagoshima. And I flew down and I actually went to look at how the customers were actually using our products. And so what we noticed again on the production floor that they basically were able to automate. So this company does cleaning, etc. for all the local hospitals. It's a really big operation. It's pretty much all autonomous, the folding, the ironing, the cleaning. There's maybe 2 or 3 people managing this whole sort of floor. All of these things are pretty much automated. Yet what was interesting when we actually went to see how they were using our product, the way they were handling their data entry, you know, was still very manual, and it was taking a really lot of time. There was a big bottleneck there. And so I worked with the company itself to fully measure and understand how they were actually using the system and how their operation was working. And so what's interesting here is that we were able to sort of map the before and after situation once they were starting to use our product. And so they had this very large sort of data labeling, you know, component, and then there was errors and verification. They had to make sure the data was correct. And then when we introduced our system, Smart Read, we were able to process these documents. So we, you know, there was an additional time there that didn't exist before, which was scanning. And then suddenly, you know, the kind of workflow changed. But overall, we were able to roughly reduce the time by about 50%. Now, what starts to become interesting here is that the accuracy of your AI model is not the value that you are selling to your customers. And this is a very important point that I sort of want to start on, is that often in deep learning, there's an obsession with accuracy, but that accuracy itself does not translate directly to the value that you provide to your end users. So what really you need to start understanding is the relationship between the overall value provided, and in this case, when I went to see the customer, it was basically time saved for them, you know, labor cost reduction. That's usually for most customers of our product. And so we then are measuring the accuracy of our model, which kind of reads characters and understands documents, and try and find a relationship between that accuracy and the overall value that we're providing. So that brings us to what I term the value accuracy curve. And that basically is saying that there is some relationship that maps between the accuracy of your underlying AI model and the value that you give to the customer. And there are different kinds of relationships that you can imagine existing. So the bottom curve, the one here, that is a situation where your deep learning or AI model will have a very limited value unless it's almost perfect. So if you think of sort of like, you know, Tesla's autonomous driving or our product, unless you're pretty much close to perfect, that value of that model is not really very high. You know, if you're 99% accurate for a self-driving car, which means that you will have a crash once every 100 times, that would not be acceptable. And the value of that car would be close to zero. And so the challenge is to really try and move from this curve at the bottom to be the curve at the top, the straight line. Now, if you think of other domains, for example, a recommender engine for Amazon, even let's say at 70% accuracy, that model will still have value. So let's say that they recommend me 5 books. 2 of the recommendations are not good. 3 of the recommendations are good. There is still value in that system because even when you make a mistake, the downside is not very big. So the challenge is really to try and make your problem sit on that curve that's a straight line. Because if you are at the bottom curve, it will be extremely expensive for you to solve that problem. We're talking hundreds of millions of dollars. Or you may have to sort of reduce the domain of the problem. So the way we were able to solve this, and I think that this is an important point, is that we were able to put a human into the loop for our system. So while our system required, the overall output has to be close to zero, the AI model would make mistakes. We created an interface where we could quickly identify and correct the mistakes that our system was making. So the other way to look at that is through the idea maze. This actually came from one of the partners, Anderson and Horowitz, which I think is very interesting, is you can make an MVP, you can have something that's 89% accurate for an AI model. And then the question is, how do you get the rest of the 10 to 20%, the long tail? It kind of gets difficult. So one way to do that is to create this user-tolerant, basically an interface that will help the human, put a human in the loop. So this is what we created. And you'll see the document on the left side. We're basically doing the OCR, we're extracting information. And on the right here, we present to the user the result. And if they're happy with the result, they can just very quickly verify the document is correct. In a few, in a small percentage of cases, you can make a correction. So what's interesting here is that now we could start operating without the model being perfect, yet we were still able to deliver value. And this, I think, is very important to understand, is that as a startup, or even if you're launching a new project, getting to 100% accuracy is very difficult or impossible. You need to figure out a way of creating value when the system is not perfect. And good user interface is very important. It can be a way to solve this problem. Now, the reason, what happens then is that you start changing the priorities of how you're building the product. You don't focus just on the AI. What you start focusing on is the interaction between the human and the AI. And so that interface of, for example, giving confidence or somehow creating that link between the AI system and the human using it, and making that work very well, changes the priorities of the company. Whereas initially, you could imagine just having a lot of engineers who are constantly trying to improve your model. The focus is really on deep learning, trying to improve the accuracy. Here now, you're starting to think about, okay, I maybe need some UX designer. I need some really good way of understanding how humans are interacting with my system. And this will most probably require to rethink the kind of people that you're sort of building the system with. So the other thing that was really a challenge is to think of like what actually accuracy means for us. So for us, again, we were reading documents. If you look at this credit card as an example, you could read every number correct and then make a mistake at the end, for example. So now the question is your model 93% accurate because you've made one error out of those? Or is it 0% accurate because you have the wrong credit card number? So because we, for example, were using an interface, you only have to correct one number. And so our model was 93% accurate. There is still value there. If we didn't have the user interface, the model would, again, have that kind of zero accuracy. So the interface can change, how you measure accuracy, but not just that. Defining accuracy in a meaningful way is something that is actually more challenging than people really understand. Now, this brings me then, if we continue along this, is that you can start understanding, once you start understanding this relationship between your model accuracy and the value that you can start providing, you can get a notion, even before you start, roughly, how accurate does your system need to be before you can create commercial value? So this is important if you're doing a startup, or even if you're doing a project internally in a company, that even before you're starting to commit resources, you can get a rough idea of how good your predictive model needs to be before you can be commercially successful. And of course, then, once you have, let's say, this idea that my model on a certain data set within a certain domain, and minimum, for example, has to be 85% accurate, anything above that, I can create a product. Then you need to go, how do I get to 85% accuracy? And of course, the typical answer is I need more data, right? So the challenge is, how do you get the initial data? And there's been a lot written on the internet of how you get started. So you create a free service, for example, to get the data you need. You try and find a public data set. You get a POC, or you kind of create your own synthetic data. So there's a lot of stuff out there. What worked for us was a combination of working with a few customers and getting that POC data into our system, and then augmenting that. And so joining with real data, and then kind of creating more synthetic data. So you will see some images here in the early days. We don't use this anymore, but this allowed us to get an accuracy that was high enough to get out an MVP. And so we were able to generate, all of these are synthetically generated, sort of handwritten and printed with lots of varying noise. And we were then able to train our model to actually get the initial version of the product out. So then we're moving now a little bit away from the kind of the standard theory is that what you want to do once you have an MVP out is that you can have this kind of great virtuous cycle where, users will give you more data, the product will get better, and then more people will use the product. And so this is the theory of the data network effect. Now, unfortunately, the theory has kind of proved not to be 100% correct, because if you think of the standard network theory of the Airbnb, of the Uber, of Facebook, the idea was that as more users are using the system, the network itself gets more valuable, sort of the network effect. The idea, at least in theory, was that AI companies could have the same kind of growth simply because they were accumulating more data. But that's actually proven to be somewhat false. And the reason for that is, first of all, is acquiring that data can be challenging. Getting more of that data is not always easy. But one of the biggest challenges is that data is not exponentially increasing on making your model better. As you can see in the graph, typically, the more data you get, at some point, you just need so much more data to get a smaller amount of sort of benefits. So there were moments where we found that you need to, double or triple the amount of your total data set to get, several % of accuracy increases. So the idea that you just get more data and somehow this will make your company just grow on its own, I think that's been proven false. And for us, that was definitely the case, because you reach this plateau where more data doesn't really help. And the other issue with that is issues of data model regression, and I'll talk about that a little bit later. So Anderson and Horowitz then sort of looked at, and we've experienced this, is that really AI companies don't really operate like standard standard software companies. They actually have lower gross margins, scaling challenges, weaker defensive modes. And really what we found is that, compared to my experience previously building software, is that by building a company that uses deep learning, you are adding a completely higher level of complexity. And the standard books, or the standard theory from 2001, after the dot-com bubble, you had the lean startup, you iterate quickly, 2-week iteration cycles, sprints, you can quickly A/B test. That really doesn't work once you are dealing with these much larger models and the complexity in the cloud. It's really the rule books around how to build a successful AI business, I don't think are really out there yet. And I think that the industry is still trying to understand what is the best way to both have keep the knowledge that we've learned, after the dot-com bubble of quick iteration, but dealing with actually a much more complex problem in a way. So some of the reasons why, for example, your margins are lower is that you've got a much higher cost, basically. So training models in the cloud or on your own hardware is generally much more expensive, something that normal software companies don't generally deal with. Model inference can be expensive. We've got hundreds of clients, millions of data kind of points coming in every day. And so our cost of just running that operation on the cloud is a lot larger than what a typical SaaS company would have. The other one is things like rich media. Generally, AI services have things, like speech, images, videos. So just storing a lot of that data is a lot more complex than I think, a lot of other companies before. And the other challenge is that the operations on the cloud, when you're running a simpler kind of business compared to when you're running deep learning models, is that the overall operation is a lot more complex, basically. The other challenge is also data labeling, and there are costs around that. You may have to have an operation where you hire people simply to label your data, and then there's a whole cost associated around that, not just in terms of human cost, but building tools for them. Okay, so basically this then brings me on to some of the challenges and some of the solutions. In no particular order, I've just put some of the points that we've had to deal with. And how do you deal with getting deep learning models into production? And how do you actually make a product where deep learning is a sort of core component? So one of the things that we found is that you always need a lot more engineers than you need deep learning researchers. I almost think the ratio is maybe 1 to 10. While you can hire, and we've hired some very great, clever engineers that work really just on the deep learning model, the real big challenge, in addition to building the deep learning models, is knowing really how to productionize them, put them onto the cloud, make scalable data pipelines, constant monitoring, etc. So there's a whole sort of operation that needs to be managed, and so the ratio is actually very much skewed. You'll need a lot of engineers who can kind of run this. It's just getting some super good researchers from the top university is not going to allow you to productionize. So the other thing that was interesting for us is that we had to build a lot of tooling just for data labeling, and this was software that would not really go directly to the customer. So we had to create, user interfaces. We had to create the way that we store data, et cetera, just for the ability, let's say, to have 10 people labeling some of the data that is coming into our system. So the other challenge from a business perspective was also how to decide when a new model can be released. So if you were just to say, well, I now have a model and that is on average of higher accuracy than the model that we had 3 months ago, from an engineering perspective, the engineers could go, we've reduced errors by 3%, let's deploy this. Now, the reason you can't do that, especially if you're in a B2B environment, is the one customer. So on average, the model may be better, but one customer may be negatively impacted. There may be regression for one customer. So what we found was that we had to really get the business side involved to look at every time a model was going to be updated, and whether that could actually go into production or not. So the other challenge, when you're dealing in a B2B environment, so we work in Japan with some very large customers, and when they use our service, it's not our service alone. It's generally integrated with a host of other systems, and it can take up to 6 months for your system to be tested as part of a much larger sort of installment. And so even if you were then to change your model, even if the model is more accurate, the behavior or the impact on other systems can actually be a problem. And so how do you deal with that is a challenge that, every company will have a different one, but if you're working in a B2B space, it's something that really needs to be kind of taken into account. So for example, one of the projects I worked on with a large bank in Korea, and we were working with another partner, and they had an ML component, they had a deep learning component that would be trained on our output. And so we then produced a new updated model, and then their model had to be retrained, but the people who were doing that retraining were not available. And so these are the kind of challenges that one has to take into account. So the other thing that's also interesting from, and a challenge, is that you can sometimes have, your model makes a bad prediction, your model makes a bad output. If you sort of bring that, it's difficult to know sometimes whether that is actually a bug in your code, and it's something that can be debugged, or it's actually, well, just the model doing what deep learning models do, and they sometimes make mistakes. So what we've had to do very carefully is look at systematically the errors that our models make and make sure that these errors basically have a normal behavior. So for example, when we make predictions, if you're on average making the same errors for most of your sort of characters, then that's okay, most probably then the model, and there is no bug. And if you see a misprediction, that's most probably fine. But if you're seeing that 90% of your errors are coming on in a one specific type of either character or situation, you then most probably need to say, could this potentially be some bug in the code? So distinguishing between bugs and model behavior is something that is a challenge and needs to also be addressed. Actually, one thing to add here that's not on here is the other thing that we learned is that there's a very different kind of set of needs required for deep learning researchers when they are building and prototyping new models versus when you want to take a deep learning model into production. So our analogy is that you have a wind tunnel. So think of a small model of an airplane where an engineer can very quickly go in and make sort of large changes to the system. So, I'm going to add this, I'm going to change this. So you really want a system that's very responsive, and you want the ability to quickly change code, to really quickly experiment, to get the best sort of deep learning architecture. But then you need to go into production, and what we found worked the best is to take a certain deep learning model and basically recode it from scratch and say, now we're moving this into production. We're going to recode this. So it's handed off from the deep learning researcher to the engineers who can now maintain that in a sort of systematic way. It's all recoded. So the model will still now be retrained, but you're no longer in an experimental phase. So one of the challenges that, again, needs to be overcome is to have a very good handover between prototyping and productionization, and kind of understanding how that works. What we tried in the very early stages is we had this prototype, and then we try to put that into production directly, and it just, it caused more problems than actually rebuilding everything from scratch. So the other challenges is that, from a machine learning side, it's still new, the technology. So there are lots of competing frameworks, and making the right choices around that is not sort of trivial. So we've, just had to experiment around and find the tools that work for us. So the other challenge is that you may have a changing data distribution over time. That's not so much of an issue for us. Generally, people's handwriting doesn't change very much. But one of the challenges is that the data that you have, the underlying distribution may be changing. And so you need to track that. The other challenge that we've had, or generally the challenges that exist, is that you may have multiple deep learning models feeding into each other, not just with external clients, but internally. For example, with our system, we've got deep learning models which will detect the location of text. We will have deep learning models that will group certain text together. We will have deep learning models that will translate an image into characters. And all of these models, the output of one is feeding into the input of the other one. And so you need to basically, once you're testing the accuracy of a particular model, you need to ultimately test it in the context of the overall thing, because again, one model that's better may overall be impacting the downstream system in unpredictable ways. So really testing things in as a whole has to be done. Okay, so we've covered these. Yeah, so the other thing that's very interesting is that people will also sometimes just really focus on model accuracy. The problem with that is that you still have deployment constraints. So while you can prototype a model that has this amazing accuracy, it may be really large, it may be really slow, it may be eating up too much memory, and you need to sort of negotiate between how much accuracy can you maybe sacrifice in order to reduce maybe the size of the model, the speed, etc. And that needs to be sort of communicated. Generally, the way people think, it's all about the accuracy, and then you've got a model that is very difficult to deploy, or it's expensive to deploy. So having these discussions early on is very useful. We've talked about another interesting aspect about accuracy. There's something a little bit funny about human nature, is that let's say that you have a model that on average does very well. In our case, let's say we read characters very well, but sometimes we make a mistake on reading a simple digit, like 1 or 2 or 3, and we make a mistake. But we can read, really complicated Japanese writing. The way humans perceive something to be good or not good is quite related to how we perceive the world. So when humans or customers perceive that you've made a mistake on what they think is easy, there is an inherent idea that your product or your model is somehow not very good. Yet if you make a mistake that a human makes a mistake on, that's kind of forgiven. So sometimes overall accuracy is not the right measure. You need to, and this is our experience, my experience, is that when you're dealing with customers, what humans perceive as easy, you really want to make sure that you get that right. And if you make an error in what humans consider to be difficult, it's kind of, you can get away with it. And so what that means is that you may want to weight the way that you measure accuracy differently, and not on an absolute level, but on almost like, what is the perceived value from the customer? And that's a kind of interesting idea that I became aware of more and more of. If you have an autonomous car and it goes through a red traffic light, that's seen as like, oh my God, this system is completely bad. But if it makes a mistake when it's raining on some little country road, somehow that's seen as more acceptable. But that doesn't translate into how difficult the actual problem is. It could be the red traffic lights are actually much more difficult than navigating on a country road, right? So that's some kind of an example. So the other thing to consider is running on GPU or CPU on the end customer side. If you're sort of deploying or even on the cloud, that's just something to take into account. Like, where are you going to deploy, and is that always feasible? So the other challenge is that compared to normal software, these models are just very large. So you've got gigabytes that you need to move around potentially versus megabytes. So you have these kind of large artifacts, and dealing with that in itself is a challenge. Securing models is another challenge. So if you were to deploy your system on premise, protecting your model, the deep learning model, is more challenging than just protecting normal software code. And especially B2B, we, for example, had to deploy our code, our models, our solution on-premise, and protecting or securing deep learning models is not as trivial and not as easy as protecting sort of software code. And so that's another thing to consider from a security standpoint. Well, I'll skip this last point. Okay, and so this is my last slide. What I'd like to talk about now is just some of the challenges around just AI in a B2B environment, and just B2B in Japan in general. So I mentioned this already. So humans assume accuracy should follow human intuition. That's just a sort of really interesting thing as an observation to sort of keep in mind. If you have a chatbot which makes a mistake when you say, can I change address? You kind of go, the system is terrible. If you give it a really complicated problem and it makes a mistake, you're kind of forgiving. So I think that should really be kept in mind. Again, challenges of updating models when you have regression. On a B2B environment, this is a really big issue. One proposed solution is that you run multiple models. So you freeze a model and you run it for a particular customer. While that solves the problem from the sort of the regression issue, now suddenly you're having to run many models either on the cloud, on premise. That's not maybe the best way to go. So handling regression is something that's a big issue. Now, the other challenge is, when you run on the cloud, you are getting more data that you can use to make your model better. But often B2B is on-prem, and you don't get access to that data. So that data flywheel is affected. So the way we operate is that we have a cloud system, and this is where we are constantly gathering new data and improving it. And we're hoping then that when you move the model on premise, that you're dealing with the same domain. And then so any improvements that you get on the cloud will help you on-prem. That isn't always necessarily the case. It could be that your on-prem customers are operating in a slightly different domain than the data that you can collect on the cloud, which means that this kind of trick doesn't work. And I specifically, I think the Japanese B2B market is very attractive. And if there are any startups or companies that are, in Europe looking to come to Japan, I think it's a very exciting and great place. The opportunity here is very large. And the last 4 points are just some of the things that I would recommend to consider. So generally in Japan, large companies will not operate directly with smaller companies. So they will operate through large SIers. So I think NTT Data is one of the sponsors of this conference. They're a partner of ours, and often we will go together. And so having that relationship with these SIers is really critical to get larger sort of clients. Now, what that means is that your customer now is not just the end customer, but your partner is also the customer. Like, how do you make your product attractive for the SIer or partner as much as the end customer? So building APIs, good documentation, and libraries are sort of critical so that they can easily use your product or engine. So often, or not often, there may be cases where you may have to move data in Japan, which means that now whatever you're operating in Europe on the cloud, you may have to run instances or data storage or whatever in a different location. So initially we had everything in the US. As the company grew, that became an issue, and we had to move and migrate everything to AWS and GCP in Japan. The other thing to consider is picking your correct platform. So certain companies in Japan will only work on certain kind of, either AWS or Azure, and knowing which industry you're trying to target and which platform they operate on it's good to know in advance, because sometimes it's much more difficult if you're on the platform that they don't really use, because then there's a lot more due diligence maybe that you have to go through, etc. So what we found is, and I'm not going to say which platform is better, it is industry specific, but being aware of that is kind of a thing to keep in mind. And really, when we talk about Asia, my experience on talking to other people in startups is that Southeast Asia is really B2C, it's a really growing population, where in Japan, really, it's that B2B market. There are about 3 million companies. And there's a lot of mid-sized companies, but overall the opportunity is very large. And so any of you who want to come and work here, I think there's an opportunity here. And I think that about sums it up for me. I'm happy to take any questions from here.
Thank you a lot, David, for your presentation. You gave us some very interesting insight about what we need to analyze when we measure the real application of artificial intelligence and how to fit this kind of technology into B2B focus in Japan. So we have some questions from the audience. I will send to you. So first, you have explained a number of issues that have to be considered by an AI-based company, which look very, very constrained. Then what needs to be considered to make still the business profitable?
Yeah, so for us again was that the user interface was very interesting. So there's something really good if, and again, this is our specific case, I don't want to generalize. Just collecting more data for us it has diminishing value. But what was very powerful is because we had a user interface, we can see where our AI model is making the mistakes, which means that we could collect a large data set of edge cases. You know, so it's the data where you make a mistake that adds you a lot more value than just data in general. You know, so when we make a miscategorization, knowing that, getting that data into our system is a lot more powerful. So one of the things that we were able to do is just start collecting the challenging kind of the challenging data, and then training on that, putting more of that into the data set. So that's one of them. But there's so many of these kind of challenges that you just need to kind of go through them. I think my point is that these are just the things that it's worth thinking about before you sort of jump in. So if you're an early stage startup, these are just the things that you just may want to kind of consider.
Thank you, David. I continue with the next question. From Europe, there is the generic perception that AI is really becoming mainstream at all levels. In East Asia, maybe particularly in Japan. Can you confirm?
So I think that there is somewhat of a misconception of how advanced I think Japan was in the 80s and the 90s. Then now Japan is still at the forefront of sort of deep learning. And I think that is not necessarily true. I think in terms of sort of the core development, I think it's between China and America. Now, what's interesting in Japan is that companies are willing to use this. So this is why I think the opportunity is there, is that there is a really, a big appetite of creating these kind of products and services. And these companies are very willing to engage with you and actually test your products out. So one thing that's great about Japan is that your customers don't look at you just as a vendor, they look at you as a partner. They're willing to tell you what's wrong with your product, and you then will improve, and together you will build something that a customer is happy with, but is making you money. So we go to customers and it's not like, well, this doesn't work, see you later. They're actually going to come back to us and say, these are the things that we'd like you to improve. Can you deal with this? This is and so it's a very refreshing kind of way of doing business where it's more of a mindset of a partnership. Now, purely in terms of AI, I don't think that there's that many. I don't think it's as advanced as people imagine.
Thank you, David. I will continue with the next one. Where are the latest methods to find out why a model produces an error an erroneous result, looking into the black box, for example, autonomous cars crashing into ambulance?
So what we do is we have a confidence measure. And that confidence measure is very accurate, basically. And so it's we have two outputs. You're outputting something of the model, which is the prediction, and you also have a confidence, which gives you an idea of how confident you are. And so we use that again to try and identify where some of these errors are. And then we categorize the errors, are all of these errors coming from the same kind of place? So error analysis, I think, is something that we spend a lot of time on to understand whether the errors are just evenly distributed or there's something specific, are you always getting one type of error more than the other? So that could be coming from the data. You could basically have something wrong in the data, and so your model is broken. We've had both, data problems where the model was just making one type of error more than it should have done. And we've also had bugs. There's been bugs of some pre-processing of the data. So in general, we just look at errors and we basically do analytics on the errors that we make to try and understand where that's coming from.
Thank you, David. Related to the latest question, so for example, here in Catalonia, we have we are part from a government strategy to accelerate the adoption of this kind of technology for the companies here in Catalonia. So what kind of support do you have in Japan related to government, and how to increase this adoption from the companies in Japan?
So in Japan, there is a big increase in just generally helping technology startups in general. In terms of adoption, it's not, I don't think that there's anything sort of really super amazing sort of to talk about. It's just that the demand is here. So, you don't need the government support. You've got basically 5 trillion big economy. All the companies are in Tokyo. They're willing to talk with you. So you don't need that. Purely in terms of developing a company, there's lots of tax breaks for people who invest into startups. Now, in terms of just providing data, this is where Korea and Hong Kong have interesting things, where Korea, for example, the government has collected lots of interesting data sets, and so has Hong Kong. And they've gone, from various places, and they've actually curated very good data sets that startups in AI can actually just get access to for free. And Japan has done some of that, but I think Korea and Hong Kong have just pushed further ahead in that regard.
Okay, we hope we can reach this kind of level in the next following years. Next question, David. I think we have 5 more minutes. You say that in your business you need more software engineers than deep learner researchers. Still, how do you manage to stay in the state of the art?
So I think there's a spectrum. So most of our engineers are aware of what's happening, and there's a lot of kind of knowledge sharing. But just in terms of a product, and this is what, user management, a good UI, storing your data in a database, making sure that you can access that database quickly. So from the customer's perspective, they don't really care that you've got this big AI model. There are still certain functionalities that you need. What's your encryption like? Penetration testing, Q&A. You need to make sure that you're releasing stuff that doesn't break the system. People sort of underestimate, what's needed there. So everybody gets excited about the fact that you have this new model and it's really accurate, but you still have a software company which requires having back-end and front-end engineers and DevOps and QA for all of that to work, because otherwise your AI model is running on someone's computer. So all I'm just saying is that to build a product in a company, you will still need, to build some of these normal traditional things. Just having an AI model is great to, speak to an investor for a seed round. But once you really want to get customers, there are certain features that you need to build, integration with Stripe, integration with the Salesforce, building connectors, automatic sort of, can you read data from, through certain connectors? Can you integrate with RPA partners? this is standard software, but you need to build it.
Thank you, Raven. Related to that, we have like some comment and also a question. Thank you a lot for the conference. It is amazingly useful. With a state, and then the question, with a state of the art evolving so fast, have you realized any problems covering the business model with an intellectual property model before going to the market? And what about commercial license of datasets?
Can you read the first question again? Just
yeah, with the state of the art evolving so fast, have you realized any problems covering the business model with intellectual property model before going to the market?
Oh, like as in, have we made patents of some of the technology?
Yeah, it's related to how you protect, or how you protect your intellectual property.
Yeah, so we've basically got a legal. We've patented certain things. I mean, personally, I think patents can be sometimes a distraction because it does take a lot of time. We, as a company, we have done that, and so you work with a local office here, and so we've had several patents granted. Again, this is now you need Japanese lawyers, and it's quite a complex process, but it's doable. We have done, we've protected some of our stuff. I mean, a lot of this is open source, so I think the real value is when you not open source. The knowledge is out there. But just combining that with something unique that you've built, putting those two things together, that's when the value is created. And the second question.
What about commercial license of datasets?
So I don't know. Just for us, we've basically accumulated our own data set. So I don't know.
Okay.
Wouldn't have any comment.
Okay. Perfect, David. We don't have more question in the name of from CIDAI and the event organization. Thank you a lot for your time, for giving us this vision about how the real impact of this kind of technology was a very good talk on, and thank you very much for your time.
Thank you, and just one quick look so everybody can see there's Tokyo in the background. So there we go. A wonderful city. If you've not been here, please, I recommend you come and visit. Thank you.
Thank you, David.
Bye-bye.